Hi everyone, welcome back to CodeTav Management. So in last two, three videos, I have discussed about the JWT, and in the last lecture, I have mainly discussed about the OAuth 2.0 basic implementations, how the things are going on with the OAuth. So I have realized uh, we add the Spring Boot starter OAuth 2 client dependency in our projects, right? But when you add that, you probably thought that you were building a modern stateless application, but that's not. Okay. So, by default, Spring Boot secretly turns your OAuth implementation into a highly stateful cookie based architecture. Like, have you tried with OAuth with like in your application? Like, have you ever tried to test your OAuth secured API in Postman only to get blocked? Because Postman doesn't have a browser session. So today we are fixing that. Like, we are going to clarify the massive industry confusion between OAuth 2.0 and the OpenID Connect, the OIDC. Okay. So then we will discuss about Spring's default stateful behavior and write the exact code to build a fully stateless enterprise grade authentication system using ID tokens. And in the last lecture, I have discussed one high level system design, how the authorization and authentication process are going on in our REST APIs, in our applications. So if you have not seen yet, you can go to the last lecture and see from the Spring Boot discussion playlist. And today I will also discuss about the JWKS validation. So we need to think accordingly and we need to architect it in the right way. Okay. So first of all, I will discuss about this OAuth 2.0 and OpenID Connect, OIDC. So let's clear up the biggest misconception in backend engineering. Like OAuth 2.0 is not the authentication. So it is basically the authorization framework. So it answers the question like, can this application access the data? So it uses opaque access tokens to grant the permissions. And through the OIDC, OpenID Connect, we are getting the authentication, like identity, who is the user. And it provides like ID token. So always JWT plus access token. So standard scope for OAuth 2.0 is app specific, and here Open ID, that is mandatory. The ID token OIDC introduces the ID token. So it is a JWT sent to the client app containing the user's identity like sub, name, email. So if you want to know who the user actually is, you need the OpenID Connect. So that OpenID Connect sits on top of the OAuth 2.0 and introduces the ID token. So what ID token actually does? The ID token always JWT, the JSON Web Token. So it answers the question like who is the user. So it contains minimal user identity info like their email, their name, and right inside the payload itself. Okay. Now the next part is the Spring Boot stateful trap. So what is this? So Spring Boot makes OAuth incredibly simple. You add your Google or Auth properties and it magically works. But what is it doing internally? We need to know. So when you log in, so Spring handles the token exchange. It creates JSession ID cookie and stores your authentication state in the server's RAM. So it never validates the token again until the session expires. So this is why your mobile apps and Postman requests fails. So they don't use cookies, even knows if your access token expires, but your Spring session is still valid. The user remains logged in. That is a security vulnerability, not a feature. So when you add the Spring Boot starter auth to client and configure your provider like Google or Auth, so Spring automates the authorization code flow beautifully. So however, it is stateful. Like Spring receives the token from the auth server, it stores them in the server's HTTP session, and it issues a JSession ID cookie to the user's browser, and it relies on that cookie for all future API calls. And if the expiration time over, the process will happen again. Again, it will receive the token from the auth server. Then again, it will save in the server's HTTP session. Then it again issues a JSON ID cookie, and it relies on the cookie for all the future API calls. So why this is dangerous and breaks APIs? So Postman or mobile apps fail. So APIs accessed via Postman or mobile app don't inherently manage cookies. So they expect token based auth because they don't send the JSON ID. Spring blocks them and asks for login again. That's why it got failed when you request with a mobile application or via Postman. So that is the cookie based issues. So API when try to access via Postman or mobile app, they don't manage the cookies, right? So they expect some token based auth. But as there is no cookie, so they don't send any JSON ID, and that's why Spring blocks them and asks for login again. Next one is security risk. So if the actual OIDC token expires, but the Spring HTTP session is still active, like 30-minute timeout or something like that, the user remains authenticated in your system. So OIDC token got expired, but your Spring HTTP session is still active. So that is one vulnerability. Next is scaling issue. So you must now configure the Redis or session replication to share the JSession ID across multiple microservice instances. Okay, so you need to make your Spring Auth truly stateless, not stateful. By default, the Spring Boot is stateful. Okay, so to make it stateless, so to build a cloud native microservice, we must make this stateless, right? We want the user to get their ID token, store it on the client side, and send it to our API on every single request. So first step is we need to disable the session creation. So in your security filter chain, we kill the session entirely. You can see the HTTP dot this CSRF dot disable, then session management dot session creation policy, then session creation policy dot stateless. That's the main line. So we we can kill the session entirely via this stateless. Okay, and OAuth to login success handler, OAuth success handler, and we will add the custom JWT filter here. Okay, now we will do what? We will override the success handler. So like by default, Spring redirects you to a web page after login. So we don't want that. We want to intercept the success event. We want to grab the YDC ID token and return it directly to the client, not via any other page or like that, like a mobile app or React frontend. So instead of redirecting the user to a UI dashboard, We intercept the successful login and extract the OIDC ID token and return it directly to the client. So here you can see our OAuth success handler extends the simple URL authentication success handler, and there we are casting the principal to OIDC user through this, and then we are extracting the raw JWT ID token. So that user dot get ID token dot get token value, and return the token to the client like React, mobile, or Postman. So response dot set content type, this is application JSON, and response dot get write the token, the ID token. So we are extracting the raw JWT ID token and returning the token to the client. So in this way, the overriding the success handler is happening. Next is custom token validation filter. So now that the client has the token, so they will send it to the authorization bearer header. So we build a custom once per request filter to intercept it. So whenever the request comes in each request, so it will be happen like each bearer token will be there and it will intercept. So we validate the token signature, issuer, and expiry using the authorization servers public JWKS endpoint. What is this JWKS? The JSON web key set. So now that client holds the token, so they must send it via authorization bearer ID token. So you must create a custom once per request filter that is similar to the standard JWT implementation to intercept and validate it. Okay. So you can see this OIDC token filter extending the once per request filter. And then here in the header, we can get the authorization token, which is the authorization bearer ID token. Then we will remove the bearer part. Like bearer token is what? Like bearer, then that ID token, right? So then it will remove that bearer, then it will validate the token signature against the auth server's JWKS endpoint, then check the issuer and expiry, then create the username password authentication token and set the security context. Okay. Next is the JWKS validation. So do not store those tokens in your database. So validate them dynamically. All major OIDC providers like Google or Auth O, Keylock, okay, Keyclock, okay. So a well-known JWKS.json endpoint containing their public keys. So your backend uses this endpoint to verify the digital signature of the incoming ID token. So in this way, as we are not storing the tokens or we are not storing the tokens in our databases or something in our stored procedures. So that's why it is totally stateless now. So there is that like well-known JWKS.json endpoint is there, okay, with some OIDC providers like Google, Auth, Keycloak. So with the help of their public keys, we are like from our backend, we are actually calling that like using the endpoint, we are just validating or verifying the digital signature of that incoming ID token. Okay, in that way, JWKS, the JSON web key set validations happens. Now, so this stateless OAuth with the OIDC and JWT architecture is exactly what Netflix, Uber, and Amazon use. So let's speed run the interview questions and answers what are like genuinely come during the interview. So first question is why is Spring OAuth stateful by default? So it was architected for traditional server rendered web applications. Okay. So initially when it was architected, so that is for the traditional flow. That is for the server rendered web applications like time-lapse, JSP. Okay, so that basically rely heavily on the browser cookies, and the session state. The main JSession ID was the key point. Okay, so that's why by default, actually, the Spring OAuth is stateful. Now, how do you make the OAuth stateless in Spring Boot? So that I have told you with the help of this session management or session creation policy. There we can set the session creation policy as stateless. So we can set the session creation policy as stateless, and it will intercept the authentication via custom authentication success handler to return the uh, ID token to the client, and it will use a custom filter to validate the token on the subsequent requests. Okay. Now, is OAuth alone enough for user login? So no. OAuth 2.0 is an authorization protocol. So it's just delegating the access. You need to use OpenID Connect, and I have told you OpenID Connect is the layer that is on top of the OAuth to securely authenticate a user's identity. That actually provide you the proper ID token, the JWT token. Now, where is the user's identity stored? So inside the ID token, which is strictly formatted JSON web token that actually provided by the OIDC. There's actually user's identity stored with some signature or issuer. Okay, so that is the topic for the OAuth 2.0 versus the OIDC. Okay, uh, so if you like it, I hope uh, this helped you to fix your Postman API testing and scale your microservices. So hit the like button, subscribe to CodeTav Management, and I will see you in the next one. Till then, stay tuned. Bye.